Pluto. You might think this dwarf planet is harmless, maybe even insignificant, when in fact it is far from that. In this video, we're going to uncover the dark sides of Pluto, which make it the most feared planet in our solar system. As you know, Pluto lies at quite a distance from the Sun. Its orbit is around 3.6 billion miles, or about 5.9 billion kilometers. That's nearly 40 times farther than Earth. At that distance, sunlight is 1,000 times dimmer than what we experience on Earth. Daytime on Pluto is more like twilight here. You could stare at the Sun from Pluto, and it would look like a distant star, barely enough to cast a shadow. This immense distance creates a hostile environment, one so extreme that even some of our most advanced machines struggle to survive. The temperatures here drop to an unimaginable minus 375 degrees Fahrenheit, or minus 225 degrees Celsius. At that level, common gases like nitrogen, methane, and carbon monoxide turn into solid ice. Pluto's surface is literally frozen solid in toxic chemicals. But cold alone doesn't make Pluto feared. It's the isolation, the sheer emptiness that amplifies the danger. Out here, there's no magnetic field to shield you from radiation, there's no atmosphere to breathe, there's no hope of a quick rescue. In fact, if you were standing on Pluto and Earth suddenly exploded, it would take nearly 5 hours for you to even see the light from that event. That's how far away it is. Even NASA's New Horizons spacecraft, which launched in 2006, took nearly a decade to reach Pluto, arriving in 2015 after travelling at over 36,000 miles per hour. And it didn't even stop. It flew past in a brief window of time, capturing the most detailed images we've ever had. Why? Because slowing down to orbit Pluto would have required far more fuel than we could carry. That's how hard it is to reach, let alone study up close. And then there's the cosmic radiation. Pluto's distance from the Sun means it's well beyond the protective bubble of the heliosphere, the region of space dominated by the Sun's solar wind. Beyond that bubble, space is filled with galactic cosmic rays, high-energy particles from exploding stars, and other extreme events in the universe. These particles tear through electronics, break molecular bonds, and wreak havoc on anything unprotected. In other words, Pluto is sitting in one of the most radiation-intense environments in the solar system. So yes, Pluto may be far away, but that's not a reason to feel safe. It's a reason to feel uneasy, because the further you go from the warmth of the Sun, the more the universe reveals its most dangerous traits: extreme cold, relentless radiation, complete isolation. And Pluto, it sits right in the middle of all of that, a silent, frozen guardian of the edge. And maybe, just maybe, a warning. But Pluto's danger isn't just in where it is, it's in how it moves. You see, most planets follow a relatively neat, flat path around the Sun, like marbles gliding across a disk. But Pluto ignores the rules. Its orbit is wildly tilted, 17 degrees off the plane of the solar system, and shaped more like a stretched out oval than a circle. This means Pluto doesn't just orbit far from the Sun, it dives above and below the solar system, crossing paths with Neptune's orbit in the process. That's right, Pluto actually enters the domain of another planet. At times it's closer to the Sun than Neptune is. Between 1979 and 1999, Pluto wasn't even the outermost planet. We gave it that title, but it wasn't true. And yet, they never collide. Why? Because Pluto's orbit and Neptune's orbit are locked in a kind of cosmic choreography, a resonance. For every 2 orbits Pluto completes, Neptune completes exactly 3. It's a gravitational dance that prevents them from crashing. But resonances like this aren't permanent. Over millions of years, tiny gravitational nudges from other planets, or even rogue bodies drifting in from the Kuiper Belt, can destabilize orbits. One small shift, one ripple in the balance, and the harmony could break. Then what happens? Well, if that resonance fails, Pluto could spiral into a chaotic new orbit, crossing paths with other objects, or even be slingshotted out of the solar system entirely. Worse, it could bring it dangerously close to the inner solar system, where its gravitational influence could begin to disrupt the delicate clockwork of planetary orbits we've come to rely on. This is part of what makes Pluto so feared. It's a wild card. It's a relic from the solar system's early days, still following rules we barely understand. And it reminds us that the solar system we know is only temporarily stable. Pluto is a crack in that illusion, a glimpse into a system that isn't locked down forever. It moves strangely, it defies the pattern, and it tells us that chaos still lingers just beyond the edge. Pluto moves like it doesn't exist, and as it turns out, it breathes like it doesn't exist either. While most planets have atmospheres that remain fairly stable, Pluto's atmosphere is more like a ghost. It appears, and then it vanishes. At certain points in Pluto's orbit, when it gets a little closer to the Sun, its icy surface begins to warm up. Just barely. And that's enough to trigger something wild. Solid nitrogen and methane on the surface begin to sublimate, turning directly from ice into gas. Just like that, Pluto grows an atmosphere. Thin, fragile, and unstable, but real. Now remember, this isn't like Earth's atmosphere, which you can breathe and live in. Pluto's atmosphere is made of things like nitrogen, methane, and carbon monoxide, all dangerous to humans. But the weirdest part isn't what it's made of. It's what it does. When Pluto begins drifting away from the Sun again, its thin atmosphere doesn't just cool down, it freezes and falls. That's right. The atmosphere literally snows down onto the surface and turns back into ice. The sky collapses, the planet suffocates itself. This cycle of appearing and disappearing atmosphere is unlike anything else we've seen in the solar system. It's not stable, it's not reliable. It's a delicate balance that seems to hang by a thread. And there's something else, something stranger. In 2018, astronomers observed Pluto as it passed in front of a distant star. They expected its atmosphere to thin out as it moved further from the Sun. But it didn't. It actually seemed to get denser. This defied everything we thought we knew. Some scientists think there might be a complex thermal lag, meaning Pluto's surface is still warming from its last close pass to the Sun. Others suggest unknown chemical or surface processes are at play, but we don't really know. What we do know is this: Pluto's atmosphere doesn't behave the way it's supposed to. It pulses in and out of existence. It resists prediction, and it might even be hiding secrets we haven't uncovered yet. In fact, the more we study Pluto's atmosphere, the more questions we have. It's like the planet itself is responding, reacting, alive in a way that feels more like a system than an object. Pluto may be frozen, distant and small, but it's doing something planets aren't supposed to do, and that makes it all the more mysterious and all the more terrifying. Up close, it reveals something deeply unsettling. It's not dead. When NASA's New Horizons spacecraft flew past Pluto in 2015, no one expected what it found. Scientists were ready to see a dull, cratered ice ball, a fossil of the solar system's past. But what they actually saw shook the scientific community. Pluto wasn't just icy, it was dynamic. It had structure, motion, activity. One of the first things that stood out was the enormous, heart-shaped region on Pluto's surface, now famously called Tombaugh Regio. But this wasn't just a visual quirk. The western side of the heart, called Sputnik Planitia, is a 1,000-kilometre wide plain of solid nitrogen ice. And it moves. That's right, the ice is flowing, like glaciers do on Earth. The nitrogen isn't just frozen in place, it's actively reshaping the surface, pushing and pulling over millions of years. In some regions, it even rises into convection cells, bubbling upward from below, like a pot slowly simmering, in solid nitrogen. Why is this so strange? Because Pluto shouldn't have the energy to do this. Internal motion requires heat, and Pluto is supposed to be too small and too far away from the Sun to hold on to any significant internal warmth. But there it is, moving, shifting, alive. And it doesn't stop there. Pluto's surface is littered with cracks and fault lines, some stretching hundreds of kilometres. These aren't caused by impacts, they're the signs of expansion, as if the entire planet once swelled up from the inside. Some scientists believe Pluto may have, or once had, a subsurface ocean buried beneath its frozen crust, an ocean of liquid water. Let that sink in. On a world over 3.5 billion miles from the Sun, where the temperature hovers hundreds of degrees below freezing, There could be a liquid ocean trapped beneath ice. If it exists, it may be kept warm by radioactive decay deep in Pluto's core, or by some insulation process we don't yet understand. Other icy bodies like Jupiter's moon Europa or Saturn's moon Enceladus are known to have subsurface oceans, but Pluto isn't supposed to be in that club. It's too isolated, too cold, too small. And yet here it is, breaking the rules again. This raises unsettling possibilities. Could Pluto harbour some form of primitive life in the hidden depths of that ocean? Is there geological activity, cryovolcanoes, thermal vents? All that we've missed because we've only had one brief flyby? We don't know. And that's what makes Pluto frightening. It's not just a cold, distant rock. It's active, moving, and potentially even hiding an alien ocean beneath its icy skin. By now you've probably noticed a pattern. Pluto doesn't behave. It doesn't orbit like other planets. It doesn't sit still like a frozen rock should. It moves, it breathes, and it spins. Like a wild card, Pluto's axis, the imaginary line it spins around, is tilted 120 degrees. For comparison, Earth is tilted at just 23.5 degrees. That tilt gives us seasons. But Pluto's tilt, that gives it extremes. Picture this, on Pluto the sun can hang directly above the horizon for decades, barely moving, before plunging into a night that lasts nearly a century. One entire side of the planet can be in darkness for over 60 Earth years. This tilt means that Pluto's seasons are not just intense, they're brutal. When its northern hemisphere faces the sun, the southern plunges into darkness and cold, unlike anything we experience on Earth. Temperatures drop, the atmosphere collapses, and ice creeps across the surface like a living force. Then slowly, Pluto swings around. Light returns, ice melts, the atmosphere resurrects. The planet flips again. This cycle doesn't just shape Pluto's surface, it erodes it, reshapes it, destabilizes it. But here's the kicker. Pluto's rotation is also caught in a gravitational bind with its largest moon, Charon. The two are locked in a perfect tidal dance. Pluto always shows the same face to Charon, and Charon to Pluto. No other planet and moon system in the solar system does this. This means that Pluto and Charon don't just orbit each other, they orbit a point in space between them, like two figure skaters spinning around an invisible centre. It's eerie, it's precise, and it makes Pluto's motion even more complex. And on top of all that, Pluto's orbit is influenced by the gravitational tug of other distant bodies in the Kuiper Belt. These forces nudge and wobble its tilt over millions of years, meaning its orientation, exposure to sunlight, and entire climate system are in a long-term state of chaos. Some simulations suggest that Pluto's tilt could change so dramatically over eons that its poles could eventually face the sun directly, flipping its seasons in ways we can barely imagine. So what does all of this mean? It means that Pluto is not in balance. It is spinning, wobbling, shifting, and lurching through space in a way that screams instability. It's not a frozen relic. It's a system on the verge of change. A planet, or whatever it is, caught in a centuries-long storm of motion and light and darkness. Pluto's dance with Charon is already strange enough, but they're not dancing alone. Orbiting this bizarre binary system are four smaller moons: Styx, Nix, Kerberos, and Hydra. At first glance, they might seem like insignificant chunks of ice, quietly circling the chaos below. But like everything in Pluto's realm, they're far from ordinary. For starters, their orbits don't follow the neat, orderly patterns we see with planets, and their moons elsewhere in the solar system. Their paths are elongated, tilted, and constantly influenced by the tug-of-war between Pluto and Charon. They wobble, they spin erratically. Some even flip end over end, with no stable rotation at all. Take Nix and Hydra, for example. They tumble chaotically through space, their poles swinging in every direction over time. Imagine a football spinning wildly as it flies through the air, but for decades or centuries at a time. Scientists have described these moons as being trapped in a state of permanent chaos, where their rotations will never settle into a predictable rhythm. This is because Pluto and Charon's powerful combined gravity destabilizes their smaller neighbours. constantly nudging them. The surfaces of these moons are unexpectedly bright, covered in fresh ice, possibly from material blasted off by micro-impacts or even from interactions with the insubstantial gas escaping Pluto's collapsing atmosphere. But the true danger of these moons isn't just their weird orbits or shiny ice, it's what they tell us about Pluto's violent past and future. Some scientists believe these moons are the result of a massive ancient collision, possibly the same event that created Charon. In that scenario, debris from the impact formed a chaotic ring around Pluto, coalescing over millions of years into these odd little moons. But that raises a chilling question. Could such a collision happen again? Pluto is still surrounded by a swarm of icy bodies in the Kuiper Belt, many of them on unstable orbits. Any one of these could be deflected toward Pluto, triggering another cataclysmic impact. An event that wouldn't just alter Pluto's moons, but could destabilize its entire system. And there's one more unsettling thought. Because these moons spin so chaotically and orbit such a distant, shadowed world, we barely know them. They've only been photographed once by New Horizons, and only from a distance. Who knows what secrets they hold, or what dangers they might hide on their scarred, icy surfaces. In Pluto's neighbourhood, even the smallest things can turn deadly. And that's just the tip of the iceberg. Pluto is not alone out there. It's the most famous member of a vast, dark, frozen region known as the Kuiper Belt, a sprawling disk of icy bodies, debris, and ancient relics left over from the birth of the solar system. The Kuiper Belt is no peaceful graveyard, it's a cosmic minefield, and Pluto is sitting right in the middle of it. There are an estimated 100,000 icy worlds in the Kuiper Belt, and perhaps millions more smaller fragments. Some are the size of mountains, some are the size of entire cities, some, like Pluto's distant cousin Eris, are even larger. These bodies are on unstable, overlapping orbits, constantly tugged by Neptune's gravity, nudging each other into new paths, sometimes hurtling them inward toward the inner solar system. And Pluto, it's caught in the middle of this invisible war. Though Pluto is currently in a delicate resonance with Neptune, meaning their orbits are synchronized to avoid collision, nothing is forever. The gravitational tides of the Kuiper Belt, the subtle tugs from other dwarf planets, and even the chaotic interactions with its own moons could eventually throw Pluto into an even more unpredictable path. Some astronomers theorize that over billions of years, Pluto could be ejected entirely from the solar system, flung into deep interstellar space like a rogue planet. Others suggest that Pluto could one day destabilize part of the Kuiper Belt, sending a wave of icy bodies crashing inward toward the gas giants, or even Earth. And if that sounds far-fetched, consider this. Some of the most famous impact events in Earth's history, like the asteroid that wiped out the dinosaurs, may have originated from the icy realms beyond Neptune. Pluto, with its volatile atmosphere, its chaotic moons, its shifting tilt, is not just a bystander, it's a gatekeeper, a sentinel standing watch over a realm of forgotten monsters. So what makes Pluto the most feared planet in the solar system? It's not just its strange orbit, or its violent moons, or its explosive surface. It's that Pluto is a reminder of how fragile order is, of how easily chaos can seep back into the solar system from the shadows beyond. Pluto is the frontier, and frontiers are dangerous places.